Hi Ahmed, I'll present to you the introduction for our machine learning project. Our team, Kevin, Shiqi, Rita, and I decided to use a Kaggle competition dataset called Dogs versus Cats. The dataset contains 25,000 images of dogs and cats. Each image has a file name as its unique ID. Our purpose of this project is to create a classifier capable of determining from a photo whether the animal is a dog or a cat. We assign dogs a value of 1 and cats a value of 0, as you can see here in the Jupyter Notebook. Also, we did some basic data exploration and visualization using several libraries to upload the images and convert them into an arrays. During the cleaning process, we found one file that was empty and we took it out. In addition, we split the datasets into training and testing datasets, giving 80% for the training and 20% for the testing datasets. Then we normalize these digits to be a float between 0 and 1. During the preparation process, we have faced some problems. For example, we could not run the models in our local machines. For some, the computer froze, and for others, it took very long time to run one model. It wasn't efficient to test and run multiple models, so we went ahead and built everything into the Google Cloud. From there, we were able to run and test multiple models in a timely fashion. That's it for my part, and thank you for listening.
Hello, I'm Xu. I'm going to present the second section. I'm going to share the screen. Okay, here is the code. This section includes two parts. The first part is prepare the data. The second part is build the model and change the parameters to optimize the model. Okay, at the beginning, we use the OS library to upload all the images. Then I can get the file name and the file path. So I built a data frame for them. Then I group by the category, get the number of dog images and cat images. Actually, we can find that the data set is balanced. Then we use the PIL library to convert the images into digits. Here we use the grayscale. Then we plot several images so that we can know what the images look like. Then we ship the data. Then did the normalization. At last, we split the data into the training data set and the test data set with the test size 20%. Okay, the next part is the building models. First, we use logistic regression as the baseline model, but the accuracy is very low. So we change the model into the random forest. First, I tried the 500 estimators. Then I got the 64% accuracy. So I'm thinking maybe I can try more estimators. But after I tried the 1,000 estimators, the accuracy doesn't improve so much. It is just 0.36% accuracy. And I made the computer matrix for this result. Here is the computer matrix. So I decided to update the model again. So we use the deep learning. Then first, we install Keras and TensorFlow in Google Cloud. Okay, we start the model with fewer layers and fewer neurons. The accuracy is just 60, so I continue to increase the layers and increase the neurons. Then I plot the learning curve. From the learning curve, we can know as the loss of training data decreased, the loss of test data increased. So this model is overfitting. So then I add the regularizers to optimize this model. At last, the problem is, the overfitting problem is solved. Here, yeah, we can see the overfitting problem is solved, but actually the accuracy doesn't improve. I mean, so much, is still around 60%. So I continue to add layers and neurons because I hope I can get higher accuracy. Then here is the learning curve. From this learning curve, we can know because the loss and the accuracy, they decrease sharply and increase sharply. So I think maybe our learning rate is too big. So I decreased the learning rate into this number. After change the parameter, the model had a better accuracy. Now we solved the problem. The learning rate is okay, but yeah, this is the confusion matrix. Then I tried more layers and more neurons, but at last, the accuracy didn't change so much. So I think the deep learning model is not good for the image recognition for our data set. So we are thinking about to update to a new model. So we use CNN. For CNN model, we fit the colorful images. The first part, they are the same. Here is the CNN model, but here the shape, extreme dot shape, the data shape is a little bit different from other models because when I feed the data to other models, I use the data which are reshaped, but here we just use the original shape of the data set. And yeah, these are the parameters. The CNN model is very, very slow. It almost took me 4 hours to run the 35 epochs. I think maybe because our data set is very big and we have so many features, but it's very slow. Here's the summary, but the result is good. At last, we got 86% accuracy. So it is much higher than all of the other models. Here is the confusion matrix. We can see from this graph, we can see that actually the label of cat and the cat and dogs, they almost have the same number that are not be recognized from this data set. And here is the precision and recall. Yeah, that's all.
Hello, Professor. This is Kevin Dragomir. I'm going to generally go over the results, and then after that, I want to concisely go over kind of the results, but within the code. So let's begin. For our project, we decided to start with logistic regression, something that's easy to interpret but holds high bias and is not the best model to use necessarily. We got a poor accuracy as a result at 53.06% accuracy. Then after that, we decided to go on with random forest. We felt that that was good because we can control the model especially when you're dealing with multiple features. We got a better accuracy than the logistic regression with the random forest at 64.06% accuracy. This model was, while using 500 estimators, we decided to go on with 100 estimators and got an accuracy of 64.36%, something that wasn't ideal, better nonetheless, but not good. So after that, we decided to move on to the DNN model, something that takes a long time to compute and can be challenging to interpret, but we gave it a shot and added a couple layers of neurons. We didn't start with a lot. With this, we ended up having a 60% accuracy. We noticed that it was overfitting. And so as a result of that, we went ahead and did regularization and got a higher accuracy. But the accuracy didn't change much. It wasn't really significant in any way. Even though we changed the number of layers and neurons, no matter how many times we kept doing that, it didn't change. So we felt that we should try a new model. Ultimately, and in the very end, we ended up going with the CNN model. This model had given us an accuracy of, I believe it was 0.8624 or 86%. And so that model ended up being the best when it came to image classification. Having fewer parameters definitely greatly improves the time it takes to learn, as well as reduce the amount of data required to train the model. And so CNN was just perfect and it worked out. Now to kind of go through the code a little bit right here. This is so as I mentioned before, first we went ahead and used logistic regression model as our baseline model. However, the accuracy was very low. So we decided to move on then to the random forest. And so this is the random forest model. Despite using both 500 and 1,000 estimators, as I mentioned before, the accuracy did not make much of an improvement. And then after that, we decided to go with deep learning. We started the model with a few layers and a few neurons, not a lot by any means. Still had a small accuracy, unfortunately, and we kept increasing neurons. But that didn't make much of it didn't have that big of an effect. It didn't change much. This right here is a graph. Here we see that the loss of training data decreases, so when that happens, the loss of test data decreases. So we noticed that overfitting was present. And so after solving overfitting, we solved that issue by adding regularization. We still didn't have an increase in accuracy, as you will see. It was still pretty darn low, so not significant. And so as a result, we decided to go with doing the CNN model in the very end, right over here. And so we used the CNN model in the end. It's a fantastic model. This is it right here. The model was insanely slow, and it took Rita a few hours to run. I think 3 or 4 hours to run, very long time. This is most likely due to the size of the data set, maybe because of features as well. Nonetheless, we finally got a good accuracy at 86% accuracy, something that's way higher than the other models, as you can see right over here. And right here, we have a short report for the precision recall and F1, all of which average at 0.86. That is my part of the presentation. That is the results. Thank you so much. I'm sure I speak on behalf of all of us in our group when I say we had an incredible semester with you, and we were glad that you were our professor. Thank you for a great semester. Bye-bye.
In conclusion, we conducted a complete machine learning workflow from choosing the data set to data preparation, to choosing the models and train on them, and finally to measuring and comparing the performance of the models. We encountered a few different challenges. One, for example, With Keras, we tried 4 models with a different number of layers and neurons, also with different regularization. But the accuracy had not changed much, so it is very hard to improve the accuracy within one model. Another thing we learned is how crucial is the Google Cloud, since it took a very long time to run just the first model in our local machine, and the computer almost crashed when we were trying DNN models. However, as soon as we built everything in the Google Cloud, we all had enough time to experiment and focus on creating more models to achieve a better result. The low accuracy in our baseline model, which is the logistic regression model, prompted us to create random forest and the DNN, so we have more control of the large number of features in our dataset. Despite getting a better accuracy, it was not that much higher than what we got with our baseline model. In the end, we came up with a model that performs the best with our dataset. We found that when it comes to data classification, the model that gives us the best result is CNN. Overall, it was a great experience and a challenging one for all of us. Yet, we got to apply what we have learned in class and learn how to deal with obstacles, and how knowing more models is like knowing more coding languages that could be more applicable to one situation or problems versus the other. That is the end of our presentation. Thank you.